Namaste children. So today we are going to begin a new chapter, Polynomials. So session 1 of Polynomials we will be seeing today. Okay. Session 1. Now, before we go into the chapter, you should have the basic facts, or you should know the basic facts about what is a polynomial and what are we going to do with that. Something you had studied about polynomials in a earlier class. We'll have a quick recap of whatever you have studied about polynomial in your earlier classes. Then we will proceed further for today's lesson. Okay. Now, we all know polynomials and algebraic connections are an expression which are connected with literal numbers and constants. Okay, there is a fundamental definitions. But polynomials are some special categories. A polynomial in x and y gives a correspondence between x and y. Okay, so always we write that y is equal to p of x denotes a relationship between x and y. We can understand like that. And this polynomial in x has got certain features. What is it? All the degrees or the powers of the variable which you are going to represent, they should have only integral positive powers. There should not be fractional powers. There should not be negative powers. Okay. For example, if you have got an expression like this, say 1 by x cubed, say, this we cannot call as a polynomial. This is not equal to a polynomial. Why? It has got a negative power here, and this also comes to the numerator, means it is a negative power. X will have a negative power. Those we cannot consider as a polynomial. Suppose if we have x power 2 by 3 plus x power 1 by 3 and then plus some other constant value. Constant can be anything. It can be 2 power 3 or anything. That constant is only, it is not going to disturb the literal numbers. So this also we cannot consider as a polynomial. Why? It has got not equal to a polynomial. Why? Because it has got the powers of the variable are fractions. It may be positive or it may be negative. Here I have quoted a positive fraction. Suppose if it is a rational number like minus 2 by 3 and then this power is a positive rational number, say 1 by 3, this is also not equal to a polynomial. Then what is a polynomial? A polynomial is a connectivity or a relationship between the variables x and y in which the variables are connected with only integral positive powers. We cannot have even negative powers. We cannot have even positive and negative rational numbers. Okay. So we should have a representation of polynomials should be some ax square plus bx plus c, like that. So where the powers are all positive. Are you understanding? So, and that is equal to y. That means the variable y is connected with x through this relationship, we can say. We can introduce a constant also and say the variable y is connected with x through this relationship, ax square plus bx plus c. So when we are able to represent a polynomial, so say ax plus b is a polynomial. So y is equal to some ax square plus bx plus c is a polynomial. Y is equal to, we can even write 2x cube plus 4x square plus 3. These are all polynomial examples of polynomials. Are you understanding? You just go through in all the examples that y is equal to degree 1, degree 2, degree 3. Now, it has got 2 terms, it has got 3 terms. This also having, the third example which I have mentioned is also having 3 terms. Now, always when we describe a polynomial, the number of terms and also the degree of the polynomial, they matter a lot. So in your earlier classes, you classified the polynomials as binomial, monomial, trinomial, and then the polynomial with 4 terms, 5 terms, etc. But now, I am going to teach you a polynomial can also be classified not only according to the number of terms, but we can classify the polynomials according to the degrees, because the degree matters a lot. Why the degree matters a lot, we will be seeing shortly. So this polynomial, the highest degree of the variable is 1. Therefore, we call this as a linear polynomial. This is a linear polynomial. This second example which I have given, it is the highest degree is 2. Or in other words, degree of this polynomial has a degree 2. Therefore, we call it as a quadratic polynomial. Now, the third is having only 3 terms. So, you have a tendency to say that it is a trinomial. Similarly, you have a tendency to say this as a trinomial. But here, the degree is 3. The polynomial 2x cube plus 4x square plus 3 is having a degree 3. Therefore, we call it as a cubic polynomial. We call it as a cubic polynomial. So, when we are classifying according to the degrees, the number of terms doesn't matter at all. A monomial can have a degree 5. A quadratic polynomial can have only 2 terms. Similarly, a cubic polynomial can have even 4 terms. So, when we are classifying according to the degrees of the polynomial, we are not too much specified about the number of terms. Got it? So, we can have only 1 term, but still it can be a quadratic polynomial. There can be only 2 terms. So, that can be even a cubic polynomial. Okay? So, it is totally different section. Okay? So, when you are classifying the polynomials according to the degrees, we have the classifications like this. With a degree 1, we call it as a linear polynomial. With the degree 2, we call it as a quadratic polynomial. With the degree 3, we call it as a cubic polynomial. Now, I want you to have a look at it. So, we are writing a cubic polynomial in this manner. Here, x term is missing, but it has got only 3 terms. But degree is 3, therefore, we call it as a cubic polynomial. Similarly, you write here, there is a x square term, there is an x term and a constant. So, we can have polynomial, quadratic polynomial like this also, ax square plus 1. So, there are only 2 terms, 2 degrees, therefore, it is quadratic. Are you understanding the difference? So, you should not get confused with the number of terms which you had studied so far and the degrees of the polynomial. Are you understanding? So, these are the facts that you should know about the polynomials. We will be further going with the concept of 0 of polynomials. In this class, we are going to study about the zeros of the polynomial. Now, when I write zeros, so that again was introduced to you earlier. In the earlier class, you had studied about the zeros of a polynomial. And then how do we relate it to remainder theorem and all these things you studied. Once again, we'll refresh. Okay. So what do we call as zeros of a polynomial? So zeros of the polynomials are the values of x for which the polynomial itself is 0. Okay, can't understand this? Just wait. Now y is equal to some x square minus x plus 1. We are writing a polynomial. I can even write one more polynomial as 2x minus 3. Y is equal to 2x minus 3 is a polynomial, say. So this is a linear polynomial. This is a quadratic polynomial. Here one thing you should understand. It represents a correspondence between x and y. Therefore, this polynomial can be plotted on the graph sheet. Yes or no? We can represent this polynomial as a graphical grid, in the graphical grid. Okay? You get some figure. It can be a curve, it can be a parabola, it can be a straight line, it can be anything. So, why? Because the relationship between x and y. Because of the relationship between x and y. So, therefore, before that, I would like you to understand what is meant by zeros of a polynomial. Zeros of the polynomial are nothing but the values of x for which the polynomial itself is 0. When you are writing p of x is equal to y is equal to 2x minus 3, the values of the polynomial is 0 means, what do you get? The y value is 0 and that is equal to x square minus x plus 1. You may not be very familiar with this type of expressions, or you have to bring it back to your memory about your earlier class lessons. But when you write 0 is equal to 2x minus 3, you would have been reminded about your linear equations. Are you understanding? So, when you write 0 is equal to 2x minus 3, we get an equation in x which can be easily solved. How can you solve it? So, we get 2x is equal to 3, x is equal to 3 by 2. So, when you substitute in this polynomial x is equal to 3 by 2, the polynomial itself is 0 or y itself is 0. Are you understanding? So, when you substitute, can we substitute and see? We have found out the values from this polynomial. Okay, when 2x is equal to 3, we solved it and got the value of x. You substitute this value 3 by 2 in this polynomial. What do you get? 0 is equal to 2 into 3 by 2 minus 3. So, that gives you 3 minus 3, which is equal to 0. Are you understanding? Now, this particular value of x is so unique. Why it is so unique? Can we find any other value to make this polynomial 0? No, the value is so unique. You can find only one value, and this value is taken to be the 0 of this polynomial, 2x minus 3. Are you understanding? Is that clear to you? Now you can put it in words. Now, let us define what is the 0 of the polynomial. Go through this definition. The value of x for which the polynomial y is equal to fx is equal to 0 are called the zeros of the polynomial. Okay? The values of x, why I have written in plural? For a linear polynomial, only one value is there, we can say it is unique. But in the case of quadratic polynomial and cubic polynomial and biquadratic polynomial, we get more than one value which will make the polynomial itself is 0. Are you understanding? Therefore, I have put the plural for x. Okay, the values of x for which the polynomial y is equal to fx equal to 0 are called the zeros of the polynomial. Now, so we'll recap the whole thing. What all I taught now? What is a polynomial? How do you classify the polynomial according to the degrees? And what are the names that we have given to these polynomials? Linear 1 degree, quadratic 2 degrees, cubic 3 degrees, 4 degrees biquadratic polynomial. More than 4 degrees, we say that the polynomial of degree 5, degree 6 and so on. Okay. Now, I want you to do a simple activity. Take your notebook. Whatever I am going to give as questions, you just write the answer in one word and give it to me. Give an example of a linear polynomial with only one term. Okay? Yes. What is that? Simply y is equal to 2x. Very good. Connect. Now I want you to give an example of a quadratic polynomial with 3 terms. Yes, I'll give a minute for you to think. Yes, you are right. Y is equal to 3x square plus 14x minus 3. Wonderful. Now, the next question is, give an example of a quadratic polynomial with only 2 terms. Yes? Yeah. Y is equal to 3x square minus 3. Wonderful. Now, I want you to give a cubic polynomial with only one term. Anybody is ready with the answer? Yes. Y is equal to x cube. Are you understanding? It's only one term, but still it's a cubic polynomial. Is it clear? Now, I want you to give an example of a cubic polynomial with 3 terms. Yes. Y is equal to 2x square minus 3x plus 5. Wonderful. So this you keep on practicing like this with the different combinations. So that is the drilling for you. You have to do it. Take out a paper. You give different example. You create your own polynomials with varying degrees and also varying terms, number of terms, and give the name to it. Let it be one term, like monomial, cubic polynomial. So that way we can write for you to understand. Quadratic polynomial with only 2 terms. Cubic polynomial with only one term. So like that, I want you to create about 15 examples totally, and you have to present it tomorrow in the session. Okay? All the best, children. Do this activity. It will be very interesting. Thank you.